The purpose of this video is to come up with a practical solution on how to generate datasets for machine learning implementations. One of the most important frames of reference for this particular task comes from the MNIST dataset, which is a set of more than 60,000 images that have a resolution of 28 by 28, and were particularly important at the initial steps of the implementation with convolutional neural networks. Our example will contain less than these 10 digits because the purpose is just to show you how to create some sort of pipeline that will allow you to receive user input in order to resize it and place it into a catalog of images that you can use and label in order to train with your particular algorithms. This implementation will be done with Python, but keep in mind that it can be extended, this algorithm, to any other programming language of your choice. So let's get started. I'm going to start by creating a new Python file called simply main.py. And here I'm going to divide the project in 3 different sections. As we normally do in this channel is the modules, which includes the libraries that other people have made so that we don't have to, the data definitions, and finally the code. In the modules, we're going to use the pygame library, which is, if you are not familiar with it, a collection of scripts that allows us to handle pixels and user input. It's normally referred to as the selected platform for making games with Python. Here we're also going to import random, and let's keep it like this for now. The basic unit of information in our system will be a tile that will be colorized relative to whether or not the user passes their pencil through it. We don't really care about colors in this implementation, but you can make modifications later if you want to do so. Let's start by create a series of constant parameters. The first one will be the resolution, and we're going to set the resolution to 32. Notice that this will be the size of each of the tiles in the system. I want to be able to see a screen that is big enough so that I can pay attention to the details while I pass my pencil through. Then we are gonna establish the dimensions of my two-dimensional grid. This one is gonna be 28 by 28. And then I need to transform the information represented in the grid dimensions into the dimensions of the screen. For this, I'm gonna multiply the resolution by each of the elements inside of dimensions, referring to their indexes. The dimensions are index 0 and dimensions are index 1. And in this case, this is a square matrix, so it is the same value. Notice the use of capital letters because these are constant parameters. The next element will be the tile. Let's talk a bit about the properties that a tile must have. A tile must have a position in the grid relative to its column and its row. And it also needs to have a color that we will change if the position of the mouse passes through that particular tile. So we are gonna specify a color and a coordinate C and R. And for reference, the position of this tile, its coordinate, will be referred to as the top left corner of that particular tile. So let's start by setting a definition for a tile. A tile will be an instance of the class, a class with the same name. The interpretation is a square of dimensions dims res by res located somewhere in the screen. And this is going to be relative to the grid. So let's start by defining a new class tile. We define the constructor, and we are going to pass the position C and R, representing the coordinates as the column and the row within the grid. So this is not X and Y, but just the particular location relative to their neighbors. And then we're also going to pass a state. And the state will be transformed later into color. The state will be a binary with integers, where the value 0 represents the color black and the value 1 represents the color white. So let's set the coordinate C equal to C the coordinate r equal to r. And then let's transform this information into pixels. And to do that, we simply multiply the value in C by the resolution, and we multiply the value in R times the resolution. That should give us the position of the top left corner of this tile in the grid. Let's talk about the state. The state will be equal to the state that we passed at the beginning. And it turns out that this state will always be 0 at the beginning, because we're going to start with a canvas that is completely black. So I may as well just get rid of this and set the state directly to 0 down here. Now that we have the state, we also need a hitbox, something that can detect when the mouse is passing in front of that tile. And that is done using a component known as rect. The rect is the instance of a class rect from the pygame library, and it receives as arguments the position in coordinates x and y where the top left corner of that square is, and that is going to be the position cell.x and cell.y. The constructor for this rectangle also receives the width and the height, how far to go to the right and how far to go down, and that is given by the resolution, which is a constant in this program. Let's create the helper function draw. And this one is going to receive no parameters other than self. And its job is to draw a rectangle that is going to be placed in a surface, a Python surface, a pygame surface that we haven't created yet. It turns out that the screen contains the dimensions of the canvas. So we just need to call another programming language that actually has the faculty of generating a screen to do so. And to do it, we set a new variable that is called display, and we're gonna set it to the pygame library, display sub library, and the set mode method. Inside, we're gonna pass the screen, and that screen will represent a tuple that tells us how many pixels wide and how many pixels tall our screen is going to be. That information can then be used down here. The rect is going to receive that display as the surface in which we're going to draw our square. Then the color. And the color will be given by a helper function that we don't have yet, but it's going to be part of the tile. It is a very simple function that could be replaced with a lambda function that simply asks to evaluate whether the state is 0 or 1, and if the answer is 0, it gives us black, otherwise it gives us white. Let's call it here self.getColor, and let's continue. The next element is going to be the rect component, and that one we already have. It's called self.rect. Let's create now the function getColor. GetColor will receive itself as an instance of the class with type self, and we are going to evaluate using an if statement if the color should be black based on the state, and if the answer is no, then we can simply return here the color white. Now that getColor is defined, we can move ahead and think about generating our grid. If you have seen other tutorials, you may feel familiar with the process of generating the grid procedurally. In today's video, I'm just going to skip ahead and I'm going to give you the final structure. Normally, we would need to create a row. And a row is a compound data type of type list, where every item is of type tile in the data definition tile that you can see here in line 11. And the purpose is to procedurally generate these tiles within one row, and once we have one row, we append that row to a bigger structure, which is the grid. That's where the multiple dimensionality of our structure comes from. We can keep doing that and we can generate a 3D lattice or a 4-dimensional structure if we're working with video, for example. So let's generate instead the grid. The grid is a compound data type of type list, where every element inside is itself a list of tiles. Each of those elements, each of those rows, will have exactly as many tiles as we specified in the constant called dimensions in the index 0, which represents the number of columns. In other words, a row will have as many tiles as we specified columns in our constants. And we're going to have as many rows as we specified in the number of rows in the constant dims. The interpretation is a two-dimensional array of tiles. So let's start by creating an empty grid, which is going to be represented by an empty list. Now remember the steps of procedural generation. Regardless of which programming language you are going to be working with, these same steps usually apply. The first thing is going to be creating a for loop that will run for as many rows as we want to create inside of a grid that has the dimensions at index 1, which is the total number of rows. For each of those, we're going to add two steps. The first one is to generate a row, which is creating the object. The second one will be to populate it, and once we have it, to append it. So, to create a row, we need to iterate again. For every column, in a range of values that goes from 0 to the total number of columns that we specified, we create a tile. And a tile will be created by calling the constructor of the class tile and passing the position C and R in which this tile has to live. Then we are gonna append this tile inside of the row by typing row.append, and we're gonna append this tile. Once we are done, we get back to the procedural generation of the row, and once we finish generating a row, we can append it to the grid by typing grid.append, and we append that row. And that's it. This is a two-dimensional structure. Let's generate a quick template for it. You'll see the utility of a template in a minute. In line 43, I'm going to type the best structure that allows me to visit every single item inside of this grid, and that will be a for loop, where the loop variable is named based on what lives inside of this grid. We didn't make a data definition for it, but that is technically what a row is. So let's just call it a row. For every row in the grid, we can do anything we want to do, but we do it to the row. These three dots here represent actions, something like print, a function. However, each of our rows is also a compound data type of type list, so we can repeat the process. In this case, the items that live inside of a row are tiles. And for every tile in the row, we can do anything we want, but we do it to the tile. This two-dimensional structure, this nested for loop, is the most important piece of information in the entire program. Now that we have this, let's see if we can draw our tiles. In the coding section, we are gonna start by generating two functions called draw and update. And for now, I'm gonna leave the placeholder called pass so that we don't get any execution errors. This program is gonna call the function draw and update forever, unless the user halts the execution of the program manually. Here, in the draw function, to draw anything with pygame, I need to follow three steps. The first one is to pick the background color, which technically is optional, but I really like to do in case I made any mistakes, which happens quite often. I can say display.fill, and I can fill the background color with something very bright. In this case, something bright is good, because it will let us know where we have gaps within the grid. In theory, if everything works well, we shouldn't see any red at all, because every pixel in the screen is being covered by a tile. Then we can do anything we want that is specific of our program, and then at the end we call for a handshake that is gonna connect this programming language, that is Python, with the programming language that is actually in charge of the surface that generates the pixels. And that one we're going to access with the command flip. In the update function, if you're working through Replit or any other service on the internet that provides an editor for Python, you usually don't have to worry about this. But if you're running this in your computer, this may be important. And I guess that is better if I demonstrate what I mean by this. So let me see if I run it, and let's see if we run into any issues. Okay, there is no errors. So if I click in this window, however, my program gets angry at me and it doesn't let me do anything. So the problem is that the window is non-interactive. As soon as I try to modify it, the program halts. And actually, it gave me an issue here. There it is. I think it finished running. To fix that, I need to tell the program that I'm listening to the events from pygame. And to do that, I can use a for loop that goes through every single event in the list of events of pygame that I can access using the method get. So if the event is of type quit, which notice I'm typing as a constant here, then I can call the quit function from within pygame, and that will allow me to close the window. If I run the program once more, and actually I'm going to reduce the dimensions of the resolution. I'm going to set it to maybe 16 because they're now to be quite big, 28 by 28. There it is. It's much easier to handle. I can move the window now. I can just put it wherever I want. And now you can see why I decided to work with tiles rather than pixels, because now I have a space where I can have a little bit more control without having to sort of close my eyes and try to focus on which pixel in particular I'm trying to color. This way I have a little bit more of space to move my hand. Okay, but the grid is not there. The color is still red. And to fix it, I go to the template for grid and I paste it here in the middle of this sandwich inside of the draw function. And I just fix the indentations. Whoops. Install formatter. The formatter should have been there all along, so I don't know what happened, but let's keep going. Hopefully that's not going to come back and bite me later. So here we need to specify what we want to do to the tile. Well, it turns out that the tile already has a function inside called draw, so we just call that function. Oh yeah, this is not gonna be good. Okay, I think the tabs are correct now. Let's run this once more. And this time the screen is completely black. That is good. Let's make the grid hollowed so that we can see a little better what is going on there. And to do that is very simple. And this is just for demonstration purposes. So in line 24, which is the position where the helper function draw of the tile is located, I can simply add another parameter to the rect function, and I can type the number 1. This integer represents the thickness of a line. And by adding this parameter, the program understands that I want empty squares. If I run it this time, I have a two-dimensional grid where every single tile is represented with a hollowed square, making a grid visually. Excellent. Now that we have this, drawing is going to be relatively easy to do. In this example, I'm going to show you how to make happy faces and sad faces and angry faces. And we're going to represent these elements with labels in the file that we save once we finish working with one of these files. And the general pipeline, the general workflow is to have a way to draw something, press a spacebar, and then save it somewhere with its particular label. And of course you can make modifications. You can add another version of this where you can press a button to erase the drawing that you're working with. The next thing we're going to do, I'm going to get rid of this one for now, just so that we don't get distracted. And to implement the functionality of changing the color, we simply need to capture the position of the mouse in the screen. And every frame we need to ask if we are touching one of the tiles. And if the answer is yes, we identify which tile it is and we change its state from whatever it is to white, which would be state number 1. So we need a template again. Inside of the events, because we need to catch a particular event when the mouse button is down. We don't want to throw when we are not pressing down. We ask if the event type is of type pygame.mouse button down. Is here, I believe. And if the answer is yes, we can ask if the event.button is equal to 1. And if the answer is yes, this is the number 1 is the code for the left button of the mouse. Then let's just print hello. I just want to see what happens because it may have been 0, the code. I'm pressing the left button of the mouse and it is printing hello, so that's good. That's what I want. Okay, so here, if we're pressing down the left button of the mouse, we want to go through every single tile and ask if the mouse position is overlapping one of the hitboxes of any of these tiles. So we copy line 43 all the way down to line 45 and we paste it right there. We get rid of the comments, fix the indentations. Let's put it here. Oh geez. Indentations, please behave. Okay, so now that we are going through every single tile, the only thing we need to do is to ask. And the way to ask is with if statements if the tile is colliding not against another hitbox, because the mouse is just a point, but rather to evaluate if this is touching that point. So we say if collide point and we pass the position of the mouse that we can access using pygame.mouse.getPosition. If the answer is yes and this is colliding a particular position, a particular coordinate x and y, we can set that tile's state equal to 1. I believe that's it. If I run the program once more, let's see if it does something. Oh, it gave an issue. Tile has no attribute collide point. Oh, that is my bad. And the reason why this happened is because collide point is not a method from the tile class, it's a method from the rect class that lives inside of the tile. So the instance of the class rect is called rect with lower cases, and that one does live inside of the tile. Let's run it once more, and if I run it this time, oh, it still doesn't want to run. It says pygame.rect has no attribute collide point. Okay, after some time debugging this, I believe that the reason why this is not working is simply because I'm thinking in C# and Unity, and it's because their methods always have what is known as the camel case, where the beginning of the next word of a variable or a method always is capitalized. I think it should be collide point with lower cases, and yes, it is. And look, every time I click somewhere, that particular tile changes its color from black to white. But the problem now is that when I click and drag, it is only the first pixel that gets clicked on that is having the behavior. What we are gonna do then is to set a new variable, which is a Boolean variable called isMouseDown. And if the answer is, and if the value of this variable is true, then we can trace the position of the mouse and complete the execution of the program somewhere else. This variable will need to have credentials as global because we want to be able to modify the value of that variable from within the function. We need to create it up here. Let's create a quick data definition. isMouseDown, and the data type will be atomic. It's going to be a Boolean, and it represents whether or not the mouse is held down. The initial value for this Boolean is going to be false. At the beginning, we assume that the user doesn't start by pressing with the mouse button pressed. So now that we have this event, we need another counterpart that is going to ask if the event is mouse button up. Once the button is up, then we're gonna set is mouse down equal to false. And like I said here, it may be a good idea to ask if the button is the first one. I'm gonna add it as an AND statement because that's really the only case that we care about. If event.button equals 1. And I need to add the logical operator AND. Okay, I hope that works. Outside, I'm gonna paste the code that I had before, and this is only gonna run if is mouse down is set to true. Let's see if this works. Okay, we're making progress. It does work. Look at this. We can make a weird S or a snake or whatever that is. Okay, so this is the initial step. Now that we have an image, we also need to read a button that will save the image, and then we're gonna worry about rescaling and stuff, right? Because the final image that we are saving is gonna be of 28 by 28, where every single tile is gonna be multiplied by the resolution, which is 16. So the real resolution is 28 times resolution by 28 times resolution. Let me show you how to save your images. Let's ask if the event is of type pygame.key down, and if the event dot key is equal to pygame dot key space, I believe it's called, yeah, there it is, then we can save, right? And we're just gonna execute a helper function, say picture, and then reset. So reset is gonna be in charge of getting every single tile back to a state 0, so that we give the impression that we have an empty canvas again. And save picture is gonna be in charge of simply saving this image somewhere in our folders. To save the image as a PNG, we are gonna use this command. The value screen will be replaced by the name of the variable that represents our surface called display. And here we need to be very meticulous on what type of label we're gonna use. We need to keep track of the enumeration. And there is really two ways to do this. We can create a unique identifier that will represent a combination of, alphanumerical characters, so that the probability of two images having the same name is virtually impossible. The second one is to evaluate which files we have in a folder and then checking what is the next number in the iteration. I'm gonna try the first approach first, and maybe only, because that one is easier. We're gonna put a pin in the reset. So here we're gonna need to call another helper function that is gonna be called assign identifier. And that one is gonna get attached to the name of our labels, which in this case is gonna be given by a constant parameter followed by the text with an underscore. So I'm gonna need to add this as a strings, and this is gonna be a formatted string where the reference to that constant label will be inserted as a string, followed by an underscore, followed by the return of the helper function assign ID. Okay, let's work on the label first. The label will be, in this case, happy. And let's also assign a path. The path is going to be equal to the current location and an images folder, and let's create the folder happy in here so that we can have them organized. and I'm just gonna make them here. Notice that there is of course a way to, you know, generate a folder every time that you create a new label, but I'm gonna leave that to you as a little bit of a homework. But you probably already know how to do it anyway. So here I'm gonna just say this is gonna be the happy folder. There it is. Then we're gonna also have the sad folder, and we're also gonna say, I don't know, I'm running out of labels. Angry. Is that how you spell angry? No, it's not. English is my second language. So angry. There it is. So now we have 3 different labels. Okay. So now that we have the label and the path, it's time. You can probably foresee an error there. It's time to generate a helper function. So down here, we're going to assign ID, and also we're going to need to specify the path followed by a /, so that we can enter that path, enter the particular folder with the name of the label, and then assign the name of the image. So let's create this helper function assign ID. And in Python, you need to assign the functions before you need them. So we are gonna place it here. We're gonna need to use random, which locally is already imported up here. So here we're gonna need to say, so here we're gonna pick 5, maybe 6 numbers at random. So let's turn them also into strings. Let's set ID equal to an empty string. And for every single number that we don't really care about, so we're gonna use an underscore in a range of values that goes from 0 to the index 5 for a total of 6 numbers. We are simply gonna pick random randint from 0 to 9. That's gonna give us our digits. And then we're gonna append to the ID by saying ID plus equal, and we're gonna cast to transform the number into a string. So we're gonna set str. Good. Finally, we're gonna return the ID, and that should give us the unique identifier. So here, before I save, actually, I need to make sure that the pad is working, or at least it's something close to work. I'm just gonna paste it here, and I'm gonna try to print it. So I'm just gonna set this as the destination file, or let's just call it a file, and let's just print it down here. So print a file. I'm gonna comment line 82, and let's see what happens if I draw whatever I want. Not that it matters at this point, but if I press space, I go down here and I can see an image, and it has something that looks a lot like a unique identifier, unless I have more than a million images, which could be. I don't know how much time you're going to spend with this. But then, most importantly, it has the particular path where we want to save the image. Let's stop the program, let's run it again, and let's see if this time it saves a file. So I'm going to uncomment this. I'm going to like this one right here, right? Because it's more concise, is creating an alias. Our brains don't have to work as hard to decipher this line 81, so let's keep that file variable there, and let's run the program again. I'm just gonna I guess I'm regretting saying that I wasn't gonna make that erase button. I'm just gonna close the program right now. I'm gonna run it again, and let's start with happy. So I'm just gonna make a happy image right there. I press space, and inside of happy I should have an image, but I don't. Instead, I get an error. It says images happy doesn't even exist. It's because I never made the main folder images. So I'm just gonna make it here, images, all in lower cases, and then I can place angry inside and happy inside and sad. Run it once more. And this time, here is another happy face for you. We press space. We go down here. Oops. It seems that the editor cannot open it. And the reason why is because I forgot, as you probably noticed, to add the extension of the file. Okay, third time's a charm. I'm gonna delete this file. I don't need it there. And I can get started. So I'm gonna say, I'm just gonna make it like this now. There is one. I'm gonna type space. This time, if I go over here, I should see a print screen of the surface. And there is one. Okay. In the next tutorials, I'm gonna show you how to compress this data. For now, I think that we both have enough so that we can start working on our dataset. Oh, I'm really sorry. I was about to finish this video and I just noticed that I never created the helper function reset. And I figured that out after trying to make my own dataset. So let me set reset back to the game. So reset is gonna make use of our template. We're gonna copy the template for grid and we're gonna paste it. We get rid of the comments, fix the indentations, and we just need to change the state of our tile, So we're gonna set it here to tile.state, and we're gonna set the state equal to 0. That's it. This time it should work. So I'm gonna try making another happy face. I press enter and the image goes away. Then we have an image down here with its unique identifier, and we have what we just created. And I'm gonna show you in the next video how to compress it so that you have resolutions of 28 by 28. I'll see you next time.